Dear students, I am Nilanjani Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. So we have first of all learnt about the arithmetic sequences or arithmetic progression. Next we have learnt about the arithmetic series. Now we have come to the part geometric sequence or geometric progression. Okay. So first of all in this session we will be knowing about which sequences are termed as geometric sequences or geometric progressions. Next, we will be knowing about the general formula or the nth term formula for any geometric sequence or geometric progression. And finally, we will be solving two questions on geometric sequence or geometric progression. They mean the same. You may call the sequence as a geometric sequence or it may be termed as a geometric progression. They mean the same. So since it is a sequence, obviously we are interested in the sequence of numbers, and since there is a sequence of numbers, there will be some rule governing the numbers. There will be some rule for deciding which number can be included within the sequence and which number should be eliminated. Okay? So, what is that rule? A geometric sequence is a sequence in which each term can be obtained from the previous term or previous one by multiplying it by the same non-zero number. This is important. The multiplier should be the same number and it should be a non-zero number. Why? Suppose we are having this number 2. How to get the next term from the previous term 2? If I take the multiplier, the common multiplier as 0, then 2 times 0 will be giving us a 0 as the next number of the sequence. And if we multiply this second term 0 with a 0, we get the third term as 0. So, leaving the first term, every other term of the sequence will be equal to 0. Therefore, it is important to have the multiplier as a non-zero number. It should be the same number which will be getting multiplied to a term in the sequence to get the next term of the sequence, and it should be a non-zero number. Okay? And since this is the same number which is getting multiplied, it is known as the common multiplier. Okay? And this common multiplier of any geometric sequence, wherever we have a common multiplier, that sequence is known as a geometric sequence or a geometric progression. Okay? But this common multiplier is known as the common ratio, and we denote this common ratio by this letter R. So, instead of taking multiplier and instead of maybe taking this letter M, we are taking the letter R from the common ratio. So, why is it so? I am saying that a number is getting multiplied by some common multiplier to give us the next number of the sequence. So, the common multiplier is obviously associated with multiplication, whereas we know the ratio is always associated with the division operation, right? So, aren't they contradictory? No, they are not. Why? Suppose we take 1, 2, 4, 8, indicating that it is an infinite sequence. And what type of a sequence is this? This is the first term, that is U1, which is 1. And if I multiply this 1 by 2, I get the second term of the sequence. And if I multiply this second term 2 of the sequence by another 2, I get the third term of the sequence, that is 4. 4 times 2 is 8. So it is a geometric sequence or a geometric progression. 1, 2, 4, 8, these are the first 4 terms of a geometric sequence or a geometric progression. But where is this common ratio part coming? In these 4 terms? Okay, let us take the second term divided by the first term. What is that equal to? Second term is 2 divided by the first term is 1. 2 divided by 1 is equal to 2. So, we are getting 2 by dividing the next term by the previous term. If I take the third term and if I divide the third term by the second term, the previous term, I get 2. Okay. So, when the previous term is multiplied by this number, I get the next term. Or when the next term is divided by the previous term, I get the same number. So, this is where the division operation is coming. Therefore, we write R for the common ratio. Now, you see, since this is a division, so next term is 2, previous term is 2 is to 1. Therefore, the common ratio is 2 for this particular geometric sequence or geometric progression. Okay. So, a sequence is geometric if and only if un plus 1, that is the next term, divided by un, that is the previous term, is equal to the common ratio that we have seen. In this case, the common ratio is 2. Okay. And where we have taken un plus 1 and un. So, what is n? We know that n is the term number. So, n belongs to the set of natural numbers or n belongs to the set of positive integers. Okay. The smallest value that n can have is equal to 1. The first term. Term number 1, n is the term number. So, first term is term number 1. Hence, n is equal to 1 for the first term. Okay. So, n belongs to the set of natural numbers or belongs to the set of positive integers. And what about the common ratio? Common ratio R belongs to the set of real numbers. It can be a positive number, it can be a negative number, it can be a rational number, it can be an irrational number, assert, anything. It belongs to the set of real numbers. And R is not equal to 0. We have seen why is not R equal to 0 and what happens when the common multiplier or the common ratio is equal to 0. Okay. And R is not equal to 1 as well. Why? Again the same case. I am starting with 2. So 2 times 1 is 2. Again 2 times 1 is 2. So, if you have the common ratio or the common multiplier of a geometric sequence as 1, you will be having all identical terms. You won't be having different terms in the sequence. They will all be identical terms. Okay. That is why R is not equal to 1. Now, we come to the general formula for the nth term of a geometric sequence or a geometric progression. It is un is equal to u1 times r to the power of n minus 1. How are we getting to this formula? Okay, let me take the same sequence 1, 2, 4, 8 and so on. So, n is the term number. So, first of all, let me write u1. u1 is equal to 1, right? And we have seen the common ratio is 2 for this. So, I can write this as, this is equal to 1. This can be written as 1 times the common ratio is 2. 2 to the power of n minus 1, that is 1 minus 1. 2 to the power of 0, anything raised to the power of 0 is 1. So I can write this one in this form. Okay. What is u2? u2 is equal to 2. This can be written as 1 times 2 to the power of 2 minus 1. When n is equal to 2, this is coming over here. 2 to the power of 2 minus 1 is equal to 2 to the power of 1, which is equal to 2. Times 1 is equal to 2. Okay. Similarly, what is u3? u3 is equal to 4. So this should be equal to 1 times 2 to the power of 3 minus 1. Okay. Just a moment. Yes. 3 minus 1. Sorry. It is 3 minus 1. I'm just erasing it so many times, but sorry. 3 minus 1. Okay. So 2 to the power of 2. 3 minus 1 is 2. 2 to the power of 2 is 4. 4 times 1 is 4. So this is how we come to this formula. Whatever is the n value, the common ratio is having a power of n minus 1. And 1 is the first term in this case. Therefore, we are having the formula as un is equal to, we start with u1, the first term, times the common ratio to the power of n minus 1. Okay. So we have derived the nth term formula for any geometric sequence. Okay. So now let us solve two basic questions on geometric sequences or geometric progression. Okay. First question, find the formula for the general term un for the given geometric sequence. So they have mentioned this sequence as a geometric sequence, hence it should be having a common ratio. So we have to first of all find the common ratio for this sequence. It is an infinite sequence. Let's start with our answer. u1, the first term, is equal to 12. What is the common ratio? The common ratio, let us take the second term, that is 18, divided by the first term. This is equal to 3 over 2. 6 times 3 is 18 and 6 times 2 is 12. If I take this third and the second terms, it is 27 over 18. 9 times 3 is 27 and 9 times 2 is 18. So you see there is the same number that we are getting when we are dividing the next term by the previous term. Therefore, the common ratio is equal to 3 over 2, which can also be written as 1.5. Okay. I am writing 3 over 2 as 1.5 because this is the exact decimal representation of the number 3 over 2. But in case you are having r is equal to 2 over 3 for some geometric sequence, not for this one, if you get the r value to be equal to 2 over 3, please do not convert it to 0.67. This will be giving you wrong answer. It is just an approximation. Please keep it as a fraction. Okay, I have written it in a decimal format because 1.5 is the exact decimal value for 3 over 2. It is a terminating decimal number. Okay. So now that we know the first term and the common ratio, we are in a position to give the formula for the nth term or un. So un will be equal to u1, that is 12, times r, which is 3 over 2 to the power of n minus 1. Okay, so the r value or the common ratio value is getting raised to the power of n minus 1. So this is our answer. Un is equal to 12 times 3 over 2, or I'm writing 1.5 in this place. You may write 3 over 2 as well. Since I have written 3 over 2 there, I am writing 1.5 just to show you that you can write any of them. So this is our answer for this question. Okay. So let us move on to our next question. Write the 13th term of the sequence 12, negative 6, 3, negative 3 over 2, dot, dot, dot. It is also another geometric sequence, though they have not said that it is a geometric sequence. They have just mentioned that this is a sequence. So first of all, we have to understand what type of a sequence this is. Only after that can we apply the formula. So let's start. Now you may see we have learnt about the arithmetic sequence, so we may just try to get the common difference. Minus 6 minus 12 will be giving us minus 18, and minus 3 over 2 minus 3 is definitely not equal to negative 18. So it is definitely not a case of an arithmetic sequence. Next, let us try a geometric sequence. Okay, so it is okay, first of all, let me write U1. U1 is equal to 12. And now we are checking for the geometric sequence. So we have to check whether there is any common ratio existing between the terms. I'm taking the second term. It should get divided by the first term. Negative 6 over 12 gives us a value of negative half. What about the third and the fourth terms? It may be, if I take the third and the fourth terms, the numerator will be having negative 3 over 2 and the denominator will be having the value of 3. Okay, and I have seen, I could have taken the second and the third terms, but deliberately I have taken the third and the fourth terms because I have seen many students having problem with the division whenever they are having a fraction in the numerator or a fraction in the denominator. Okay, if you have a fraction in the numerator or in the denominator, or both in the numerator and in the denominator, what do? You just write it in this form. Minus 3 over 2 divided by 3. Okay, so this is equal to minus 3 over 2 times 1 over 3. And these two can get cancelled and you will be having the ratio as negative half. This is also equal to negative half. Therefore, this is a case of a geometric sequence. Hence, we can apply the nth term formula to get the 13th term. Okay. So, r is equal to negative half. Again, in this case, it is a terminating decimal number, so I can write this to be equal to negative 0.5. But as I have said before, if it is not a case of a terminating decimal number, please do not convert it to a decimal format. Keep it in the fractional form. Okay. Now coming to the 13th term. U13 is equal to U1, which is 12, times r. It is negative half, I am writing, to the power of n minus 1. That is 13 minus 1. Okay. So this is 12 times negative half to the power of 12. Okay. So this can be written as 12 times negative 1 to the power of 12 times half to the power of 12. Okay, I've just taken out that negative sign so that no confusion arises. And negative 1 to the power of raised to the power of an even number will be giving us a positive 1. Okay, so basically this is equal to 12 times 1 over 2 whole raised to the power of 12. And if it is a question from the non-calculator paper, your final answer will be this one. But if in case this is a question from the with calculator paper, you can use your calculator to find a decimal value for the 13th term. Okay, now let us use the calculator. So, and it is 12, and over here in the denominator it will be 2 to the power of 12. So 2 to the power of 12. Okay. So this should be equal to 0.00293. So this is equal to 0.00293. Okay. So this is our answer. I'm just writing the decimal value over here. It depends whether it is a question from the with calculator or without calculator paper. So this is our final answer. Okay. So students, let us stop over here for today. We'll be meeting very soon in our next video session. Thank you for watching this video till the end. Please give this video a like if you found it useful. Please subscribe to my YouTube channel and do not forget to press the bell icon. You will be getting notified as soon as I publish news for you. Okay? So bye for now.